Okay, so we got cut off in the last video there. But what I wanted to review and what we'll continue to do in this video is to actually work through the formula for constructing a confidence interval. So we've gone through all of these steps, and the only other thing that we need to know is the mean and the standard deviation and the size of the population. So that's find the sample mean, which is also known as X bar, find the standard deviation, or if you can't find the standard deviation, which you remember is a population parameter, you find the standard error, which is a sample statistic. And then the last thing that you need is to know the sample size. All right? So in this case, what I'm going to tell you is that the sample mean is 7.8, the standard deviation is 1.2, and the sample size is 100. So if I were going to solve this the hard way, or the long way, using the formula, all we would have to do is to be able to look here and to interpret the formula. Okay, and this formula, all this is saying is that X bar, the sample mean, minus the z-score that we found in our z-table, which we have right over here, would be multiplied by the standard deviation or the standard error, which is divided by the square root of the population size. So that sounds really tricky, but actually what we're going to do is just do that in Excel. Okay, so you can follow along. We're going to calculate the lower bound because the confidence interval is two specific values. And we're going to calculate the upper bound. So what you'll remember is that the lower bound is equal to the sample mean, which we're going to, from the sample mean, subtract, or let's see, are we subtracting or adding? Yes, we're going to subtract from that our z-score. So we're going to do this actually to start with our 90% confidence level. So we would use our first z-score here, which is then going to be multiplied by the standard deviation, which is divided by the square root of our sample size. And so what it's important to do here is to go back and make sure that you have your parens in the right place. Otherwise, you're going to get some wonky examples or some wonky results. So we're going to put that in there, and order of operations should take care of the rest. So that will be my lower bound, which is 7.992. And then what we're going to do, and actually, you'll see I've actually flipped the lower bound to the upper bound, and I'll make it right in just a second. But with our upper bound, which is actually our lower bound, we just do the same process where we take the mean, and to that we add our z-score, which is right here. And we're going to multiply that by the standard deviation or the standard error divided by the square root of 100. Okay, so our upper bound, I'm going to put these two in parens, is right here. So you can see that I have these switched around because this number is lower than this number. So let's just pop that over here. Okay, so we have our lower bounds and our upper bounds, which we calculated pretty easily using our formula. Now this is for a 90% confidence level. You could actually do the same thing. If I was going to go through, for example, just lock all of these values in without turning on the microphone. Let's see, I'll just use my F4 key. And what I'm going to do is just allow this value to drag down. So B14 is the z-score. I'm just going to leave that unlocked, and everything else I'm going to lock in. And so if I actually drag this down, 2, 3, this is going to be my 95% confidence level, and this will be my 99% confidence level. And we're going to have our lower bound, and we're going to have our upper bound. So you can see that over here what I failed to do was to lock in these values. So I'm going to go back and do that. I'm going to lock in that, lock in that, lock in this value. Okay. And then I'm going to drag that down. And what you can see is that our confidence levels shift, or excuse me, our confidence intervals shift depending on what level of confidence we want to have. Okay, so one really easy thing that you can do to kind of build an intuition about this is to actually just find the difference between the lower and upper bound. So what you can see here is that the difference between the upper and lower bound actually gets wider. You have a bigger distance between your lower bound and your upper bound with the higher confidence level. And this is what really is contributing to the additional probability that you will have type 2 error. That's what this is showing right here. Because right here, what you're saying is you keep increasing and increasing and increasing your level of type 1 error, or excuse me, the probability that you'll have type 1 error. So you're saying in this case, I only have a 10% chance of having type 1 error. In this case, I only have a 5% chance of having type 1 error. And in this case, I only have a 1% chance of having type 1 error. And here you can just see that the intervals are getting bigger, which increases the likelihood that you are going to fail to reject your null hypothesis when you should actually be rejecting it. So that's the way to do it using the formula. We can actually get the same exact results. I'm going to label this the hard way, and this will be posted on the course Blackboard site so that you can see the formulas that I have here. And I'm going to show you the Excel way. Okay, so with the Excel way, we need a few things. We need to know what our sample mean is, and then we need to know basically what Excel is going to give us is this part, this z alpha over 2 times the standard deviation or the standard error over the square root of the population. So what we're going to be doing here is to actually use that. So with 90, 95%, and 99, we're going to have these values that we get from Excel that are equal to the z that we found multiplied by s divided by the square root of n. And we're going to add and subtract that to our mean. So in order to get those values, all we have to do is go into Excel and use the formula equals confidence.norm, because we're saying that we're using a normal, there's a normal distribution here. We need to set our alpha level. So I'm going to go back up here, and I'm going to start with the 0.10, the 10% alpha level. You need to enter the standard deviation, which we have right here, and you need to enter the size, which you have right here. So what I'm going to do, because I'm very lazy, is I'm going to lock in B19, and I'm going to lock in B18. So those are not going to change, but the alpha level is going to change as I drag this down. So this is what z times the standard error or standard deviation over the square root of the size is for 90%, for 95%, and for 99%. And then what we're going to do is to calculate our lower bound, which is equal to the mean minus this Excel value right here. I'm going to lock in the mean so I can be lazy again and drag the whole thing down. So that's my lower bound. Oops. All right, and this is my upper bound, which is going to be the mean, which I'm going to lock in right here. And this is going to be plus the Excel value that we have right here. So we're going to drag that down. Now, if you compare the values that we have, you'll notice that they're a little bit different between 90, 95, and 99. That's because of rounding and the increased precision with which Excel is estimating these confidence intervals based on the data. So if I make these smaller, they'll be a little bit of a better match. But you can see they're very close, if not exact. So you see the hard way, you see the Excel way. For the exam, what I'm really concerned about is that you understand the intuition. So what are the elements of the hard way? So you should know what the confidence level is. You should know what the confidence coefficient is, how to calculate alpha, how you might go and find that alpha divided by 2 is actually the area under the tails on the Z density curve, or with the Z-score of a normal distribution, and that you can use your knowledge about the probability to find the Z-score, which we showed you here. And then that if you know the sample mean, the standard deviation or standard error, or the sample size, these are the elements that you need in order to calculate the confidence level. And you should also know the shortcut to doing it the Excel way. So that is the conclusion. No, that is not the conclusion of our mini lecture, because the next thing to do is to think very carefully about what would happen if we had a distribution that was not normal. So we've talked about constructing confidence intervals with normal distributions, right? And for that, you really need to know two things. You need to know the mean, and you need to know the standard deviation, okay? And you know how to calculate the mean and the standard deviation for a normal curve. So what happens when it's binomial, and in your homework you were told that you need to make your binomial approximate a random. That means that you need to figure out the mean and the standard deviation of a binomial curve. So here, I'm just going to bring this down for a second. We know the mean is the sum divided by n, the sum of all of our observations divided by n. And we know that our standard deviation is the square root of the variance, right? So if you ever have to figure out the mean and standard deviation, that's what those are. But in terms of a binomial, we have a different formula that we need to use to find the mean and in order to find the standard deviation, okay? And this is actually reported directly in your Moore-McCabe and your Moore and McCabe text. And the same thing is for the Poisson. You can find the mean and the standard deviation. Okay, so here with the Poisson, the mean is just the average count, and the standard deviation is the square root of that count. Okay, and for binomial, we know that we can get to the mean using the elements of n and p. So we know that the mean is equal to n times p, where n is the number of trials and p is the probability of successes, and we know that the standard deviation is the square root of n times p times, and this is a little bit tricky but not really, 1 minus p, which is just the probability of failure. So once you have these elements, if you can find the binomial mean and standard deviation and the Poisson mean and standard deviation, all you have to do is use the normal curve, our formulas for the normal curve, to find the confidence intervals at specific confidence levels. So that is what I have for you for calculating confidence intervals. If you have questions, please feel free to reach out, and I hope this is helpful. I will see you all in class next week.